And finally, the Behr disclaimer. Okay, so today's learning objectives for this course are to help everyone have a better understanding of what volume solids truly means. We will review in detail the anatomy of paint. We're going to discuss how quality additives affect the scope of color. And finally, we'll provide supporting information relating to how each additive in paint affects the quality and its performance. So what does paint do in theory, or in actuality for our purposes? We want to talk about how it protects, it beautifies, and it provides us safety. So when selecting a paint coating, majority of the time people look into a couple different characteristics. The most common reasons for selecting paint over my history of 26 years, and then also what we've dealt with and seen, is a number of different. Any guesses? This is where it gets exciting. Application. Application is a very common reason for selecting paint. The actual performance expectations. Price, always a big factor. The finish. What type of sheen are we looking at? Substrate. Volume solids. Hint, hint. And finally, quality. For years, the most common reason for selecting a paint with regard to a project was, drumroll, volume solids. So why is this such a big concern in the paint industry, or why has this always been addressed? Is for years it was always considered that volume solids, the number on a data page or MSDS page, determined the quality of a product. And with changes in technology, with changes in regulations and restrictions, whether it be a VOC or OTC laws, there's been a lot of changes in the dynamics of how a coating is made, manufactured, and then also now how it performs. What do volume solids really mean? How do they relate to the quality of price? How do they relate to film, paint film, and durability? And the big question is, does volume solids really mean it's better paint? Well, we're going to address that today. Volume solids, by definition, this is the Wikipedia definition, so we all know it's true. Ha ha ha. Volume solids is a concept in paint indicating the true volume. In layman's terms, if a data page states that the product is 50% volume solids, what we're stating is that once the coating is put on the wall, what doesn't evaporate is the volume solids. Those volume solids are going to be the different ingredients that are put into the can of paint, stated as solvent, resin, pigment, and additives. So, simplistic perspective is, what is that dry film? That is going to be your volume solids. So we're going to cover in detail the ingredients that go into a can of paint, talk about what makes some ingredients better than others, and then at the end be able to distinguish via a data page what qualifies a product as a good product versus maybe an inferior product. So I swear that I've already gained a good 30 pounds just by giving this presentation, because every time I do it, this analogy here kind of puts me over the edge, and right after lunch, I hope a lot of you aren't in the same position I'm in, but one of the ways of kind of discussing the raw materials or ingredients and what makes a difference is a nice analogy is to talk about cake. And like I said, this may have put me over the edge, but I'm sure at time to time you've attended maybe a wedding or a birthday party, and you've left there going, that cake was delicious, versus maybe that other conversation where that cake was dry, or that didn't taste so good, or we didn't like the icing. So how is that relevant to raw materials and paint? Well, basically, when you're talking about price point and quality with a cake, does that really play into it? Sure it does. But it's not always just the price alone or how it performs. Cakes are basically made the same way. But what really is going to distinguish a good tasting quality cake versus maybe a not so good tasting cake? Well, just like cake bakers, everyone can make good paint and everybody can make bad paint. But what separates good from great? It's those quality ingredients or the raw materials. Hope everybody can hear me okay, and I'm not speaking too fast. I do have a cold, so I apologize.
I'm hearing you good.
Okay, I'm good. Thank you. Excuse me. So the basic paint chemistry, or those raw materials that go into a can of paint, are listed here. We're going to cover each in great detail. But as we said in the analogy listed prior with the cake, it's those ingredients that we're going to discuss that are going to make the difference in a quality paint versus an inferior coating. So first thing we're going to talk about is the resins. That is the glue that holds everything together. You can see the listing of the three core resins that are often used in acrylic architectural coatings. The second is pigments. For this discussion, we're just going to talk about the pigments that go into the foundation of a coating, not necessarily the tints. That is another type of pigment, which I can address later if you'd like. Thirdly, we're going to talk about the additives. People are really often amazed at the amount of additives that go into different cans of paints for different purposes. And then finally, we're going to talk about the vehicle, often called solvent. That is what really just transfers the product to the surface and keeps it in dispersion in the can. So the first two segments are a little bit more in depth. The final two, we actually have a lot of pictures to kind of show and demonstrate what they do. But like I said, hang in there with me. It's some good information. So starting off with the first ingredient, probably aging myself with this screenshot, but the resins or the glue, this is the classic super glue commercial from back in the day, but basically without resin, you would just have a bunch of powder and miscellaneous additives, but there wouldn't be a way for the coating to stick to the wall. So the most common resins that are used, once again, in an acrylic or latex-based material are going to be 100% acrylic, which is the best you can make. Then there's going to be blended materials, and finally, vinyl. So let's talk about those. So 100% acrylic, now once again, 100% is the best you can get. I know there's many sports athletes out there that swear they're giving 110 and 120%, but my chemistry teacher taught me 100 is the best you can do. So for this purpose, 100% acrylic and styrene acrylic are going to be the best glues you can get in an acrylic architectural coating. Now there's different types of acrylics. So while we're talking 100% capacity as being the best, you can still get an acrylic, a styrene acrylic, benzene. There's multiple acrylics in the market that also will affect the overall composition of the product. 100% acrylic resins are the best choice in terms of quality. What they do is they provide the best adhesion possible in comparison to a blended material, which we'll talk about in a second. They also give us great stain blocking, scrub resistance, and they actually provide some alkali resistance as well. A styrene acrylic, for those who are unfamiliar, are excellent for cementitious materials. Styrenes are used in concrete mixes, and what they do is they have a high resistance or tolerance for pH levels and moisture. So if you're dealing with a cementitious project where you have tilled up concrete or things of that nature, you want to look for a styrene acrylic. As you can see here, depending on the target application, the formulators make or choose from the different resins that are available, so they're using the right ingredients for the different substrates, as I just mentioned with the cementitious materials. So moving from 100%, which once again is the best you can get in a resin or a glue, we want to talk about blended materials. So what are blended materials? Well, basically, we're not getting 100% acrylic anymore. We're moving into different types of resins or glues. They're not necessarily any less of a quality, they're just a different material. So I don't want to mislead and say that you're going to get less results in performance, but what you could get is different adhesion for different substrates. What do I mean by that? Well, an EVA, or ethylene vinyl acetate, when you're dealing with a vinyl, as most people have dealt with in the past with, say, vinyl siding, you have a lot of flexibility that you need to worry about. It's also a very permeable resin. So in a situation where you need that flexibility, using a blended material, an EVA, might be the right specification or the right product to select. So an EVA is a blend of ethylene vinyl, as I stated. It is not quite 100% acrylic, which is going to be our best glue for adhesion, but because it's a blended material, it also gives you different performance characteristics. So these features, they provide excellent adhesion over a lesser quality PVA, which I'll talk about in a second. So it's a nice interim resin to compensate if you're worried about adhesion from a lower grade material to a higher grade material. So you have a nice transition from one to the other. It's a softer resin than a PVA, which also provides some nice flexibility, but it also has more durability than a PVA. PVA, polyvinyl acetate, basically it's a price point driven resin. It is probably the least expensive resin in an architectural acrylic coating. They're excellent for adhesion to drywall and masonry, as you see here. And they're also used a lot in maintenance coatings where you don't need a lot of scrubbability. So PVA, while it's not 100% acrylic, you have that blended material, serves its own purpose as well. So moving on from the resins or glues, our 100% acrylic, and then our two blended materials, our EVA and PVA, we're now going to move into the second bucket, or second component, I should say, in the can of paint, and that's going to be our pigments. All right, hold on to your seats. This is real. Let that soak in a minute. Pigments. See what I did there? Yep, it's from the internet, so that's real. It's another one of those real things. So we talked about the resins, or that's the glue that holds everything together. We have 100%, we have the blended, and then we have the less expensive vinyl. Now we have pigments. So once again, the pigments I'm discussing here are more related to the foundation of the granules that accept tint, but tint is also a pigment. So just to differentiate the two, I hope that was clear. So what do pigments do? Well, pigments provide our whiteness, They provide our hide or our wet hide and dry hide, how well the paint covers. And they also are going to impact color. So as you can see here, the pigments that are listed, the best pigment in the market or used in the industry and architectural coatings is going to be titanium dioxide, TiO2. Then we move down to a clay or a talc. And then finally we get into the calcium carbonate and silica. Once again, listing them from best quality to more inferior quality. So what differentiates those two core pigments, the titanium dioxide from the extender pigment, which is going to be your clay and talc? As you can see in the example on the left, the titanium dioxide, it's a mined material, ground very fine. It stacks on itself. It's usually spherical in nature, and it gives us a very dense pigment, which provides us excellent hide, both wet and dry. It also allows a very tight film. So what does that mean, or how does that translate? That gives us extra durability. It doesn't allow it to collect as much dirt. It also washes and cleans a lot easier, and will give us a longer length. I'm trying to talk here. Of the coating. It's going to give us more durability over time. So extender pigments like clay or talc, if you think about those from like a baby powder or something of that nature, they're very dense. But what happens when we add some water to, say, baby powder? It's absorbed, right? And it kind of breaks apart. So what do we have there? We don't have the durability that we're looking for in a coating. But why would we even use an extender pigment? Well, cost is going to come into play. But outside of that, we need to look at the reason for extender pigments in performance. Let me show you the next example. This is actual under a microscope, and you can really see how the titanium dioxide, TiO2 on the left, really does have those spherical orbs, how it is a much denser film compared to the conventional or extender pigments, where you can see they're very jagged. The other thing we want to look at is the whiteness of the actual materials. So titanium dioxide, most people don't even realize, but it's in almost anything that has a very pure or clean white. So you can actually find TiO2 in your toothpaste, or maybe your paper towels or tissue paper, in regular paper as well. Titanium dioxide is used across the board in many different things. So titanium dioxide in its form is a very clean, and it's basically the whitest white in a pigment compared to your clay or your talc. So what does that do? Well, it's going to limit us when it comes to color selection, or be able to create a color. If you don't start out with a clean, crisp white, you're going to be very limited. So I'm sure you see that a lot when you're coming across a commercial grade material. You'll find that in a lot of the products that are going to be made with the extender pigments, these clays and talcs that I've discussed, the color selection is going to be far more limited. You're going to have your off-whites to start out with, and they're most commonly used in your fit-outs and your repaints and renos, or whiteouts as they call it, to basically give us a nice clean finish, coat it, touches up well, but then it's not going to give you that durability that you're looking for. So, for a tenant fit out, you're just going to make everything look pretty. You put down your more inexpensive commercial grade materials, and then you come back with the higher grade, starting with the titanium dioxide and 100% acrylic resins. So there we're going to get cleaner colors, more vibrant colors, and then we're also going to get that durability that we're looking for. So once again, whiter pigments like titanium dioxide, the whitest white we can get in this architectural coating, will give us a larger range of colors to choose from compared to those extender pigments. As you see at the bottom, we're starting white to black from the left-hand side, and as it works across, you can see how it starts to muddy up the coating on the spectrum of color. I don't know if anybody's ever seen this before, but it basically shows the broad range of what we call the standard color selection. And you're limited to the earthier tones when you start with an extender pigment, where you're given more vibrant colors when you use the titanium dioxide. All right. So we've talked about the resins, the glues that hold everything together. They give us adhesion to the surface. They also provide some durability and scrubbability. And we've talked about the pigments. Pigments as the foundation of the coating, that's what's going to give us our whiteness and our wet hide or dry hide. They also affect color selection, as we talked about, the titanium dioxide being the brighter white. Now we're going to get into the additives. Once again, I hope there's some laughing going on behind the scenes there. Probably aging myself, but the mad scientist there for additives. So there's different additives used in different coatings. You're not going to find these additives in every type of coating because, once again, they're going to be specific to the substrate or the performance characteristics that it is expected of the coating. But a lot of additives that are used in coatings are going to affect the performance and also application. So these are the three most common additives, and then I'm going to get into more in a second here, that go into a can of paint. Surfactants, a lot of people in areas with high moisture have heard this term before. Surfactants, basically, they help with the flow and leveling of product. They also help hold everything together or help it coalesce. Biocides, I'm sure many of you have heard of the term biocide or mildicides that are used. A lot of the times, people mistake this biocides and mildicides as an active ingredient on the surface, whereas more often than not, the biocides or mildicides that are added to a can of paint or to prevent growth in the can, they don't really translate to the surface. So that's a conversation you might want to have with your coatings manufacturer and myself. And then finally, thickeners. They're going to affect viscosity, sag resistance. That's really going to come into play when we're talking about application. When you're rolling the surface, putting paint on with a roller versus spraying, the different thicknesses that build up, you could get some sag, or you could have some running going down the wall if it's not made for that type of application. So let's dig in a little bit deeper here. Some of the additional additives that are put into a can of paint: wax. As you would expect, when you hear the word wax for like flooring purposes, they're going to provide improved water resistance. But in addition, it also provides some scuff resistance, durability when you're talking about flooring, walking on it, enamels, things of that nature. Silicone is also often used in a lot of the coatings these days for when we're talking about UV resistance or fade of colors, especially when we're talking about exterior exposure. Silicone also offers a great amount of water resistance. So what do you get there? You don't have the penetration of water into the substrate or the film, which leads to less failures. We do have mildew inhibitors, so that's going to be different from your biocides and mildicides in the can. This is an extra additive that are going to help resist the growth of mildew down the road in a coating. Biocides, in addition, we can add for a lot of healthcare facilities. They're going to help resist any type of microbial growth. Once again, they're not fighting that bacteria, they're just helping resist the growth of on the film of paint. Surfactants, I already spoke about. So surfactants, often, in layman's terms, that's soap. So you're going to be adding, basically like you would think of Dawn detergent. You add Dawn soap to a coating, it helps it flow and level. But when you add basically soap to a can of paint, if you put the lid on it, put it in a shaker, took it out, and opened the can, you'd have bubbles everywhere. So to counter that, we have to add a defoamer. And then finally, those thickeners that we talked about. They're going to affect the sag and drag, which a lot of contractors will refer to, also the total viscosity of the product, and then the rheology. So once again, the pictures here are just kind of to give you a visual of the different additives that we spoke about, or I spoke about a second ago. So what does the wax do? Wax is going to give us some mar resistance. That's the top left picture. That is a product that doesn't have wax in it. It scuffs up, and you'll see that on the surface, whereas a product that does have wax in there will resist that marring. Gives us some durability, like you see on the left-hand side. You can actually scrub off different types of ingredients that might have found their way to the coating, whether it be pen or crayon or mustard or ink. Wax provides us a lot of scrubbability and durability. And finally, that water resistance. That does provide some nice characteristics to a coating where you're not going to have that bead up of the actual coating, the dry film coating, because there's wax in the coating, the water doesn't penetrate, it beads up, and you have longer longevity in the expectation there when it comes to total product performance. Silicones, what we're seeing here on the left is silicone provides a lot of flexibility in the coating. As I spoke about earlier, not only does it give you some water repellency, but it also provides some flexibility. So silicone does a nice job of sealing the surface, but in addition, when you have a situation where you have a hard-to-grip surface, or something that expands and contracts, or something that's actually just difficult to adhere to, a product that will have silicone in it will provide you that extra ingredient that you need to give you the performance characteristic, of that coating. So this is something you would want to look for or talk to your coatings manufacturer about. Mildicides or fungicides. Once again, here we're talking about resisting the growth of. These are additional additives that are added to the coating. You'll see these a lot when you're talking about high moisture areas, whether it be bathroom coatings, your kitchen, or areas that have a lot of moisture exposure in the continental U.S. is what I'm talking about. So where you have a lot of mold and mildew growth, you want to find a product that has some mildicides, fungicides added to it, so that you don't have performances like you see here. Bottom left is sadly a little mold or mildew growth on some trim. And then also on the exterior coating here, this is a tank, but going up their stairs you can see how that mold and mildew growth really does a lot of things. Not only does it not look good aesthetically, but that mold or mildew is going to eat into the coating and really affect its performance. Biocides, once again, just some visual depictions of where you would see biocides. There's a lot of talk today about biocides being added into coatings. Are they doing anything to impact indoor air quality? Simple answer at this point is there are really strict guidelines in place that limit coating manufacturers to the amount of biocides they can put into a product. Basically, everything goes through EPA testing, and in order for a coating to claim it has biocides, it has to pass these stringent, very strict and stringent laws, regulations. What these biocides do, once again, and I know I'm being repetitive, but they're helping prohibit the growth of any type of microbes. They're not killing the microbes. So it's not an active ingredient, meaning that it's not reacting, it's just preventing in the dried film. Surfactants, once again, I kind of explained that a second ago, but basically what that does is a lot on your trim or your doors. You want to have a product that has a good amount of surfactants in there so that it impacts the flow and leveling of the product. You usually have more surfactants in your higher sheens. What that does is allow the product to kind of coalesce and pull itself together so you don't see all those brush strokes like you would see. So once again, we're looking at basically soap being added to the product, and you could get things like the fish-eyeing or the outgassing or bubbling like you'll see in that bottom picture if the right amount of defoamers aren't added to the actual can of paint. When we're talking about thickeners, or they impact the sag resistance. So the yellow photo there shows poor sag in a product. The right amount of thickener might not have been added depending on the application. So what we're seeing here is, was the right product selected for the right application? And what we mean by that is maybe this was spray applied. And the product was not meant to be sprayed, so it had less amount of thickener added to it, and we're getting this runoff, if you will, which is going to affect it mostly aesthetically, but at the same time, if you're looking at touch up and finish, you're probably going to see a variance in the color or the sheen on this actual dry film. So once again, reaching out to someone like myself or your coatings representative, depending on the application, you want to make sure you're selecting the right product there. Excuse me. So we've talked about the resins, talked about 100% acrylic, and we talked about our blended materials. We're talking about the glues there and the resins, what helps stick to the wall. We talked about our pigments. That is the actual foundation of the coating, whether it be titanium dioxide or an extender pigment. We just went through our additives. So there's some of the additional ingredients that might be added to a coating depending on the actual coating and the substrate that it's being specified for. And finally, we're going to talk about the vehicle or liquids. Sometimes it's also called solvent. Drum roll, here it comes again. See what I did there? Vehicle, liquid. All these things are on the internet if you want to look them up. So the solvent or the vehicle, basically what that does is that delivers the coating to the surface. That's usually what evaporates. It's not part of the volume solids. When we're talking about water-based material, it's simply water. For getting into solvent materials, it's going to be your xylenes, acetone, methylethyl ketone, paint thinner. A lot of times it's very easy to distinguish what the vehicle is by looking at what you're cleaning up the product with or thinning the product with. It's that simple. How do I do it time-wise? Oh, good. So once again, the vehicle, it's what you're going to use to dilute the product, to thin it. It dissolves the resin or the binder for when it's dry, we're talking about, so to help you with cleanup. But what it does in the can is it holds everything in suspension with the pigment, so you don't just have a big tie-dye swirl of material in the can. The vehicle holds everything together. Once again, the oil-based or an alkyd paint is usually organic material, so it would be a paint thinner, the xylene, once again, and then the latex paint simply is water. So a quick review once again. The reason of this course, so the main purpose of this course was to help distinguish the difference in volume solids. To kind of reiterate or maybe break it down a little bit further, what we're getting at is previously a lot of specifiers would look at the volume solids on a data page, and if it was a higher volume solids on the data compared to a competitor product, they would think automatically because it had more volume solids, it was a better product. I hope that the time we took today in explaining that 47% vinyl is not equal to 47% of an 100% acrylic glue really is going to be the distinguishing characteristic of a quality material versus an inferior material for a job. I know it's kind of making things more complicated for the specifier because we're asking you to dig into the data page, but we need to realize that not all things are created equal. Not all products are created equal. So in the end, paint manufacturers can have equal ingredients as far as quantity of volume solids, but if the quality of the ingredients is not there, you're going to have a huge variance in the performance characteristics and expectation of the product. So lower volume solids doesn't necessarily mean that you're getting a less quality product. Let me say that again. If you have a lower volume solids of a certain ingredient, it doesn't necessarily mean that you're going to get a less quality or performance of the product. It's kind of hard to take in. So I hope I hit on some of the core pieces of how to differentiate a product. Talked about the 4 core ingredients or components that go into a can of paint. Hopefully I haven't confused you, that I've given you some good knowledge and information to go back whenever you're dealing with the paint specification that will allow you to distinguish a quality product from an inferior product. And then also giving you some ideas of things to look for when you're specifying specialty projects or jobs or different substrates so you can select the right coating for that project.
Thanks,
So,
John. We'll
we'll
give it a second, see if there's any questions. Really good presentation. Here's my bad pun of the day. It was better than watching paint dry.
Yeah, and I usually say I'm the guy who gets paid to watch paint dry. So. Well, I appreciate everybody. I hope it wasn't too dry. I'm an East Coast guy, and I apologize for that. But I like to try to have a little bit of fun. I mean, to your point, we are the people who get to watch paint dry for a living. But we realize it is very challenging for architects and specifiers these days to really know how to select a quality product. And this is where hopefully some of this information is valuable in helping you dial in. And once again, the easiest way for most is just to reach out to your coatings manufacturer like myself.
No, I really enjoyed it. It kept me awake the whole time.
That's good.
And for everyone else, once again, when we end this presentation, you'll be given a survey at the end, and just please fill it out. If you need CEUs or certificate, let us know. And then if you need the AI credit, please include your AI number. And no questions came in. So, John, once again, oh, wait.
I was taking that as a compliment.
One question snuck in there.
Such a good job. Nobody had questions.
Does the vehicle selection make a difference in product quality or performance?
So, no. It's the other. The vehicle basically just holds everything in the suspension there and keeps it together. The vehicle is usually what evaporates. 9 times out of 10, that is the ingredient that evaporates. I didn't get too in-depth here. When you get into specialty products, high-performance coatings, it's a little bit different. For this example, or for this presentation, I tried to make sure I specified that it's mostly architectural latex coatings is what we're talking about. So in that case, it's water. The water evaporates. A lot of your lighter industrial coatings, your direct-to-metals, things of that nature, the vehicle is not going to impact the quality or the performance because it actually evaporates off the surface, and it's those other ingredients, the pigments, the resin, and the additives, that are going to give you performance characteristics.
Very good. All right, everyone. Well, enjoy the rest of your week, and until next month, thank you. And thank you, John.
Thank you all. I hope you have a great day.
Thanks.
All right.